Hello everyone. In this video I will talk about moving from monolithic architecture to microservices. And I will discuss why the reasons why would we move from monolithic service to microservices, and we break down the monolith into smaller services. And specifically I will walk through hands-on a scenario that I've done in one of the companies I had, and the reason that showed that we had to move to the microservices to be able to scale up. The companies, they can't scale up and they can reach a point that it's a bottleneck to depend on one monolith service. And in this scenario I will explain how the AppSync and Amplify came to the rescue to be able to give us the new solution with less budget and actually less refactoring. We used one of the patterns that I will explain called Strangler pattern. So let's go together in this journey and explain to you how I've done it and what are the known patterns moving from monolith to microservice. So first, let's discuss what's monolith. We've been hearing this a lot. Monolith is that, any company when they start small and they build like have few features and then they start adding more services, more servers. They grow, the database grow, the app, they start adding to the same app. It's easier. Oh, more features. Oh, add more to the same app until it explodes. And this is the monolith actually, that it's easy to keep adding to the same app when most of the companies they start, they don't know, they're still trying to experiment something, so they didn't plan to grow quickly. But if suddenly they grow quickly, they have a lot of customers, they start growing. Even if they decided to use auto scaling and they scale the same app, but it's the same code base. It keeps growing, deployment gets slower, and then everything will slow down until it stops. So, what's the solution for that? Okay, let's first discuss what are the issues with the monolithic architecture and why we need to change. So the monolithic architecture, actually the main problem is the large code base. That's a big problem. When you start, you say, it's a small service. Let's add this together. Let's add here, reading from the queue. Let's add it to the same service. Why would we spin another service, create containers and all of that? So we keep adding to the same code base because it's easier and faster until it becomes a mess and becomes bigger and bigger. Anyone that's coming new, if the team left, if it's moved to another team, it becomes a burden on the new team or new people to try to understand what's going on because everything is strangled together and it's also very hard to test. The second issue is tight coupling between all the components. As the code grows, everything will be coupled together. One change will break the entire system. Try to change something, you will find regressions in the entire system. It will be very hard to try to test the entire system, and you'll find tests are failing, so you get rid of the tests, and it will be like the spaghetti over there. It's just very hard to try to break the mud bowl, as they say. Sometimes they call the monolith as the big mud bowl. So tight coupling is one of the problems, and it's this against the open close principle. One of the basic principles that's very important, I learned them like more than 20 years ago in the object-oriented design, is the open close. Open for addition and close for modification. Try to build a system that when you try to add a new feature, it's open for addition. You can add a new service and have communication with the old service. And close for modification. When you find yourself you have to modify the entire system or old components and create regressions to add new features, this is a red flag. It's against the open close principle and creates regressions and it will affect the entire system. Also, it's less scalable. As I said, you can't scale up. That's the problem of monolith. It's very hard to try to scale without breaking the system. And there are limits for the vertical, if you try to do vertical scalability, because it's one app, one service. more deployment restraint and restart time. As I said, it's to try to deploy, even if you change very small thing, fixed very small bug, you have to deploy the entire service, which as it grows, it becomes painful and hard to deploy this entire service. It doesn't follow another principle, the single responsibility. The one service will do everything. We'll read from the queues, we'll write, we'll change, we'll update the. You'll find different department inside the finance. The finance code, you find it just a table. You'll find the communities, the partner, everything, even the customers, the users, even the employees. Everything will be. This is the scenario that I will talk about. They only had one database in the entire company, and everything is being stored there. Of course, it has to become a bottleneck. Now let's get to the case study, and it's actually real world scenario, real life scenario that I went through in one of the companies I worked with. And we'll go hands on. I'll explain how I built the proof of concept and how to build a microservice, serverless microservice, and the facade and the gateway, as I will explain after that. So let's go and start the case study. So this is the scenario that I'll discuss. We had those issues when I first joined and when they called me to try to solve the current solution. We were not able to fulfill the business needs. We can't grow anymore. We had the business did very well, and we multiplied by 100 times. So the beginning, when they had only one database, it was Microsoft SQL, and they had one machine, and then they moved to cloud, and they have scalability. They have a couple instances with like the auto scaling, but it's not about scaling one instance. The problem was mainly having one monolith database for all domains. That's a big problem because there is a dependency. You depend on one. We said what are the problems with monolith, but also the dependency on one database and one team. This team was the bottleneck because every time you need to make a change or modification, you have to go this team. And we are tied with their resources and their time. Single point of failure, of course. Many times this happens whenever there's something wrong with the database, the entire company is down. If there is a slowness in one of the transactions, the entire company is down. Separation of concerns, there is no separation of concerns. If finance has problem, the entire company is down again. If there is a problem, someone did a bug in one of the smaller websites, internal website, the entire company would be down. There's no single responsibility. I've explained this before. Explosion of endpoints. This is problem of the REST-ish APIs that they created. Was like so many APIs, and it's not documented, and a lot of them redundant, and teams, when they come, they need something quickly, they try to build APIs, and actually most of them were just having connection strings and accessing the database directly. And separation of domains, yeah, it was one domain. We couldn't separate the domains out. It's not flexible. The design was not easy to extend without rewrite. We had to refactor and refactor again and try to do it, but it's all inside the same service. There's no separation between front end and back end. That's another problem with the design. It was built on one server, and it was actually .NET, where they need to create some quick tool. There were a lot of abandoned tool. Every time someone comes, people from the finance, for example, they have some automation. They need automation quickly, so someone creates like spin up a website on the same server, and they just access the database to try to make some queries for them, and instead of asking the developers to keep and giving them the queries to be to create an invoice. To create an invoice, actually, you have to depend on the same team, the one team that you own the database. Upgrades and maintainability for this database was a nightmare. So I remember that they wanted to upgrade from one released to another, and it was mandatory because of securities. They had to bring the entire company down for a day, and the second day only half of the tools came up, and they had to go through them to try to fix them, which for a week or more there are a lot of functionalities were down and a big loss for the company. And to be able to maintain it, it's one database again, so it's single point of failure. Anything happened to this database will bring it down. This was like totally like extreme, but that was the case. Actually, this is a real scenario, real life scenario that I've seen. But this case can, I would say this might be the worst case, but it will vary in different cases for the monolith. Like there's a company after that that I joined. It was kind of also severe, but it's not that severe. They're like multiple monoliths. So they had a monolith that the entire group or department depend on, that you get all the information from, their data from. So it was, they couldn't scale and it went down again. So they split it into another database, which was like read and write, but still one service, one database. And every time they build a service, it keeps growing because it's easier and faster. So that's why I will discuss here. There are principles for designing services to be microservices. The reason they said micro, it's very small. So it's not small, it's not very small, it's micro. That, don't be worried. It's like right now with the serverless, it can be just a Lambda and API gateway, as I will explain as well in one of the sessions. I gave it in the video how to build a microservice with just API gateway and a Lambda. And of course, if you add a database, it would be just a small thing. It's responsible for one thing. It's the owner of its own data. So as we move forward, I will give what's the best practices actually to be able to move from the monolith to microservices. Now let's see how did we came up with the design and the domains that we designed at the end. First, we've done something called event storming. It's a very interesting process where we have a lot of sticky notes and we start seeing where the events come from and how can we divide them into domains and the bounded context. I have separate actually video and articles about event storming. I would recommend that you go and read more about it. But it took like about 3 days, dedicated dates, offsites, going with the business and all the experts in the system to be able to identify how the system works end to end, what are the events that we need to, the important events in the system. And then we start isolating separate domains. After isolating the domains, we came up with 3 main domains. One of them is the customer, and then the partner and the finance. So the system actually is about marketing, some centers, apartments, and rental places that people can go. So the customers will get the find about the area or the center from our site, and then they send their contacts, and then we send the referrals to our partners, so where they can start processing it, and the partner system will move the move-in charges when they move into the place to the finance system, where they generate the invoice after they receive the move-in trigger event from the customers. And we used 2 main patterns. We use a lot of patterns, but there are 2 main patterns. We used the Strangler pattern, which helps us to migrate from the legacy systems to the microservices. And I will explain this in details actually at the end of the this video, and also in separate video that's linked here to this video. Specifically, we start identifying certain features one by one. We build the microservice, and first to build the Strangler facade, of course, which it's kind of become API gateway at the end. We used AppSync and Amplify to build this one, and Lambdas to be able to communicate with the legacy system or to the microservice, and the facade will decide which way to go according to the implementation that was implemented. And definitely the clients, the migrated clients will start moving slowly through the Strangler facade. And the Strangler pattern, actually, some people that they feel that it's a strange word, but actually, Martin Fowler, he did this pattern when he found the Strangler fig pattern, migration pattern for the tree. When you find that the Strangler application will be able to strangler the monolith until it dies. So this is specifically, I'll go in details through this, how it goes from the monolith and then the strangler branch by branch until it takes over the monolith tree. And this is how it's explained in the migration, that as you can see, from left to right, first the legacy was bigger than the modern, and then at the end it would be only the modern, and the facade would become the API gateway. And we used also, as I keep saying, another pattern called the API gateway design pattern, where you have an API gateway that kind of isolate the microservices from the client, so the client only see one endpoint, which was the AppSync in our case, and it will decide where to route the request between different services. I will talk also about these patterns in details in hands-on as well. I presented, those are actually the slides that I presented to the investors at the beginning, and explaining the difference between REST versus GraphQL. It's a big debate, but actually GraphQL solved a lot of issues that we were seeing in the REST-ish APIs. It's very hard to have a very strong and ideal REST design. So we have the current approach, and the previous approach right now to most APIs was problematic that they had. They had explosion of endpoints. With GraphQL, you only have one endpoint to use. It's definitely better performance, faster than the REST APIs. Hard to keep track of documentation and in the REST APIs, but in GraphQL, you get it for free using graphical. Hard to do the standardization. As I said, it's standard query interface. It's a standard, so there's no certain ways that you have the parameters. It's standard, everyone doing the same, and graphical will give you like hands-on. When we see the hands-on, actually, we'll see it's very easy, extremely easy to go and being able to discover the parameters and create a query. The REST APIs is not network efficient because you might need to get different parts. So you have first to get the resources and get the ID that for you want, and then you go back and do another call to get a certain member or employee from the org that you got the ID from, and then have another call to get one item from this part. And you get a lot. We call it the overfitching and underfitching. That overfitching, you get a lot of information, and then you have to process on the client side to be able to get what you want, and then you have another call to get what you get. In GraphQL, it's just one query, and you get everything in one shot. The resolvers will resolve, maybe multiple resolvers where we used lambdas will be able to resolve the requests from the place that they want, either the monolith during the migration or multiple microservices. There is, with the REST APIs, we've been facing version issues, and we keep telling people move to version 2, deprecation. We don't have the versioning issue in the GraphQL. Actually, you only add this derivative of add deprecate, and they will receive some notification that this will be deprecated at a certain point, or they will receive the notification that there is something new that will give them more information or better information, but it will not break what they have actually. So there is no need to have versioning. Also, the other thing that we use complete serverless instead of the containers. As you can see, the left side, it's the serverless. It auto scales automatically. There's no cost for idle. You only pay for the time you use. Out-of-the-box solution with AppSync, actually, and Amplify, you just run some commands, as we will see, and you'll find everything being created for you. And it's managed actually by AWS. And the right side, when you do the containers, you have to manage all the communication between different places, the load balancer, you take care of the auto scaling groups, a lot of things that you need to build. And even if you try to do smaller services, building them in containers and EC2 instances is like, it's a pain, because it's a waste also for a smaller service to build it in a container. So there's a lot of redundancy, and you have to maintain the environment. Deploying is a nightmare, definitely, and you have to bring the entire system down in this case, or the entire app or the entire service. And sometimes if you build it with code as application instead of the turnkey solution that you get it with AppSync, for example, when they build the resolvers for you, the code, as I have this experience a lot, especially with this company, is like they kept going from different technology to another, especially in the web side, as like from Ruby, PHP, and then React came at the end, and Node.js and .NET, different technologies, and they become obsolete, and you have to upgrade, and you have to move to the latest version. All of this is being taken care of with AWS in the case of the especially the AWS AppSync and Amplify. They will take care. You don't have to worry. You only provide the schema. We call it the serverless, codeless, actually, because you build a microservice, and actually it's linked. The video that I will show hands-on how to create it in a few minutes, and also at the end of this video as well. Now we come to the proof of concept. As I promised, this is where I used AWS Amplify, and in this proof of concept I will build actually a GraphQL microservices in just a few minutes. So the thing that we will use here, it's called the wizard, which is actually, it's magic that's doing. It's not magic, of course, they're using CloudFormation templates, but AWS Amplify will actually do something similar to magic. You will just provide the schema, which we are familiar with the database, so we can create the schema. We created the employee first, when the proof of concept, and we gave it to AWS Amplify, and we've done like Amplify push. It created everything, created the entire infrastructure, microservice, database, tables. We use it also Elasticsearch, and at the end it was just AWS Amplify did the work for us, and we only had to do some code for the lambdas to be able to communicate with the different systems or the legacy system. So as you can see here, this part on the left, it's actually managed and created by AWS. We don't have to worry about it. And the previous actually design that we have, the legacy system, we had like DynamoDB, Elasticsearch, and some other databases. We have to sync between them, and even during the migration, we have to use third-party tool, Debezium, to be able to sync if the data has been changed. All of this challenges has been taken care of with AWS. Of course, we had to manage by the company the Lambda that talks to the legacy system during the migration only, and after we remove them, of course, this will be gone. This is the model that I proposed, and you can see here Amplify add API to add just the API I'm showing, and this small 5 letters word adds model, the derivative that will create the DynamoDB table for us and create DynamoDB as well without even worrying about it. And at the end we just say push, Amplify push, and it will be created automatically using AWS CloudFormation. And then at the end you will get the GraphQL endpoint and the API key that you can use and add it to the front end after that. Yep, as I said, it's like straightforward. It's so easy to create. And at the end I was able, you will see all of that in the hands-on step by step. So I was able to go into the community API and community proof of concept, and in front of the everyone I was able to query and actually add some mutation. So this is the schema, and if you look into the data source, those are all the tables that were created for us automatically just in few minutes. And this is the example that I gave, like I was trying to add an employee, adding my name here, and after clicking on it, I was able to add it, receive the ID, and being able to automatically find the table that was created, the item in the table that's created for me. And when I try to query of it, of course, I've got all the information. So the first service that we built, actually first microservice, was the invoicing microservice. It was independent internal database. So this one was the easiest because we could have the database separate and we didn't have to have that much dependency in the migration to migrate the data itself. And this is the design for it. You will see the invoices microservices where the same as explained before, the clients, we build them with React and Gatsby, and then the app sync and Amazon DynamoDB, which created by AWS Amplify. We did not create those. And then we have the Lambda that will just sync with the old legacy systems. When we receive the move-in, it goes to Amazon Kinesis, and then it will trigger one of the events listeners. It will listen to the event and update the app sync, do the mutation, and then we will send another Lambda to be able to send also to, we used to have the email system using Mandrill at this point, and it will send email to the users automatically. And now the second microservice, which was actually more interesting and challenging. And as you can see, this was actually the here the same design, of course, and the same API gateway and the that we used in both. It's just the challenge here that we had is we have the writers on the old database and the readers from the new one until we finish the migration. And we used something called the Bezium for most of the cases to be able to sync between both databases. And also we use the step function as a Saga model and some of the as a state machine for, so there is a Saga design pattern as well for the transaction. Some of the transaction we need to make sure that they're written in both, and in this case we use the Saga pattern, but because this is synchronous, of course, and very slow, we use it for the very important ones, and the Bezium for most of the cases we write to the legacy database as well. Okay, so now I'll start explaining more about the other patterns. I use the hands-on as well on the remaining of the video. In this video, I will talk about one of the most important patterns called the Strangler pattern. It's used to migrate from monolithic applications to microservices. And in this pattern, as you can see in the tree in front of you, the new tree, it strangles the old tree, which is the monolith in this case, until it takes over and the monolith will die. So Martin Fowler, when he was in one of his trip in Australia, I guess, he saw this pattern happening on fig trees, where it starts with one branch or one part that will start to build, and then it will start to strangle. So one strangler branch, and then it will strangle the tree, the old tree. It's called the strangle tree, until it takes over and it will become only the microservices. The same approach we will take with migration from the monolith to the microservices by strangling slowly the monolith, progressive migration. Instead of migrating one time and building something that will take years, we just take one functionality, we build the microservice first that will replace this functionality, and we use a facade interface or a proxy that will route the calls accordingly, as we will see in the hands-on. So first, you will see that the clients are calling the legacy monolith. And instead of keeping it growing, we built first the facade. And recently, the Strangler facade, I've been using AWS AppSync as I will show in this hands-on as well. So first you identify one functionality that you want to take out, and then build the microservice that will replace this functionality and use the Strangler facade to route the calls accordingly. So you see which calls that will route to the new facade, to the new microservice, and which ones needs to go to the old one, and then we make the clients to call the Strangler facade. And then you identify another functionality, and then you remove the old functionalities from the legacy monolith and stop the calls going to it as we are seeing, and so on. Then the second functionality will also be routed, and we build this second functionality into a microservice until we remove the monolith completely. It becomes strangled by the Strangler microservices, and then after testing and validating that we're not missing anything, we move all the clients to the facade, and then this facade will become at the end API gateway, which another microservices design patterns. Well, this will become an API gateway to the REST, and voila, you've been able to migrate from the monolith to microservices. So in the next the remaining of the video, I will explain how to build GraphQL microservice using 𝒂𝒄𝒄 and Amplify. I gave it in a separate video as well. You can watch it if you don't want to watch, continue in this one. But here I will build, and I will show how easy it is. It helped me during the recent migration from in one of the companies I worked with, migration from the monolith to microservice, which didn't cost much, and it was few minutes. You'll be able to build everything and start focus on the business and the functionality, the code that you want to do for the microservice, the functionality of the microservice, but it will build the infrastructure, take care of the sync for the database and creating the database for you as well. And I will explain also in another video how to build the facade using also 𝒂𝒄𝒄 and Amplify. So I hope you will enjoy this video and learn from it. Thank you so much. Hello everyone. Before we start building microservices, GraphQL microservice, I would like to give a quick introduction to understand how to build it, the components to build it. And I'll start with the 𝒂𝒄𝒄, AWS 𝒂𝒄𝒄 and DynamoDB. So this is the GraphQL microservice that you see in front of you. It consists of AWS 𝒂𝒄𝒄, and it talks to the DynamoDB. Who builds this microservice will see the wizard that will build this actually in a blink of an eye. So this is the GraphQL microservice, and this is the final stage. For example, it would be GraphQL microservice. You might have REST microservice, that one that we built before in the previous videos, and you might have a API gateway. API gateway in this case is not the AWS API gateway, but it's an API gateway pattern, and we will use the 𝒂𝒄𝒄 as the API gateway, and it will route the code according to the right place. So you just have the schema and you do the query, and it will ask the right microservice for the right information. Now, how can we build all of that? I talked about the wizard who will build this. It's like a wizard, really. It's not magic, but it uses CloudFormation templates, but it's like a wizard. You give it the template, which is, we call it the schema, GraphQL schema, and you feed the AWS Amplify, and it does its magic with all the CloudFormation templates, and voila, it builds the GraphQL microservice, builds everything, the tables, if you have even even if you have the Elasticsearch, it builds the resolve verse by itself. And in this video, it's an introduction. We'll see how to do all of that hands-on in the next videos. This video is to explain what's GraphQL, what are the types, and what is the schema. So let's start by understanding what's GraphQL, which is simply actually its endpoint, similar to REST and standards, but it uses different way of calling the APIs and manipulating the data.
So the big difference is the way we call the API. So instead of calling APIs to get the information, you actually issue a query and you receive the information that you need. One shot. You don't have to like give multiple APIs to the call REST APIs. In addition to that, also the mutation, if you instead of post or update, you just do mutation so you can create a new value or add a new value. So it's similar to SQL database. If you're familiar with SQL database, it will give you actually the ability to query. So it's a query language, so it makes it easier. And in this case, you will find yourself being able to interact, as you can see in this diagram. You can have a resolver. So you have the query, and then the resolvers, which multiple functions will resolve the query calling either database or another service according to what is needed from them. Now let's talk about the schema. So we have the schema. It consists of the word type, which similar to class name. So you just say there is a type, which type of author in this case. So it's exactly similar to the class name, some object that will be author. And when you search, you will ask for this author to get the author back. As you can see here, the model, this is a specific, the at model that you add here. It's actually only for amplify, in this case, AppSync and amplify. When you add this at model, it will actually create a specific table for the model. So the directive model here is actually to transform this type into a table inside DynamoDB and create it automatically with Amplify. So let's grab our gears and see how are we going to build GraphQL microservices using AWS Amplify. Let's see you in the next video.
Hello everyone. So in this video, I would like to show you how can you create a GraphQL microservice by providing the schema to Amplify, and you say Amplify push, and it will create the microservice for you, including the database, the endpoints, the GraphQL endpoints, resolvers, and how they communicate. All what you need to do is just provide the schema. Let's go, and you'll find it actually very interesting journey where you find it's so easy to create the entire GraphQL microservice. And the reason is not to actually in this video to teach about AppSync. It's a very short video. I'm trying to do things quickly and without going into the theories and the details, so that the goal is to be able to use those microservices that we will build easily. The easiest way to build a microservice so we can understand the microservices design patterns in action. So let's go to the terminal, the command window, and let's start installing Amplify CLI. To install Amplify CLI, this is Mac, what I'm using. So you need to do sudo to have the admin credential, but in general, it is npm install -g to be like general in your machine. And you do install the AWS Amplify CLI, as you can see. This will take time because it will install the CLI in your machine and start configuring the machine. And I hope that you went through, before doing this, going through the article, which I will put it, I might do a video as well, but there is an article how to prepare the environment in your Mac machine. If you're using Windows, I will put some links on how to do it in Windows as well. And then next, we will try to create a React app, which will just, I know this command is like also another magic, but it will install all the needed things to create a React project. So you just say npx create React app and give it the name, which in this case is GraphQL microservice. It will take some time. After it finishes, it will give you those command, and you can go through the directory. So go into the directory that you created, GraphQL microservice, and then you start by doing code dot. Also need to configure this. I will give some instructions how to configure the Visual Studio Code. When you do code dot, we will continue working in the Visual Studio Code actually. This is provided by Microsoft, but it's open source and it's actually great, works well with AWS, and you can install things specifically for SAM, the serverless model that you can work with. To be able to start a command window in Visual Studio Code, you just do control backtick, which is the key that's at the top of the left over the tab, and you will get this command terminal. Before we go into the details of what we need to do, we can start by initializing the project by using amplify init. And most of the questions that we'll get, we'll answer them the defaults. So they will suggest a name for your project, GraphQL microservice. You have like the environment, it's dev environment right now. You will use Visual Studio Code, JavaScript, React for the front end, and then start asking for directories for build, source, and some scripts that you will use to run the project. And it will show us that it's using AWS CloudFormation. Actually, all the magic is through AWS CloudFormation. You need to create a AWS profile, which I already have profiles. I will use the default one. And after that, it will build and do the configuration for you so you can start working and building. Actually, right now, it is communicating with the console, and you can find your project in the Amplify project on the console, as we will see in later videos as well. So right now it will keep initializing and it will build, and you can keep watching it and see what it builds in there, but I will skip that and go to the screen. When it finished, it will give you, after it finished, it will tell you, okay, you can use Amplify add API to add the API to your project. And in this case, it will add the API and create it for you. But before we do that, let's go to the directory. It created a new directory called Amplify, and inside it, there is the backend where you can see multiple things. I want to just point the tags, the JSON one. It's very important if you're part of a company and you need to set certain tags, so to identify your project. So this is very important to learn. But for now, this is where Amplify will store the code for you. So let's add the API. The API is similar to what we've done in the previous videos in the API gateway, but this will be GraphQL API, which will be app sync. So it will ask you, would you like to have GraphQL or REST? Of course, we'll use GraphQL for this one, but it can also build a REST API. We will use API key for the authorization. We'll talk about this later. And then you can enter a description. This is optional, but I will skip this for now. You don't need it. It's just optional. But we will use the API key, which we will provide in our front end. You can also choose the default for this, for the expiration. 7 days will be fine. And then let's add additional changes, or you can just say I'm done and you will move on. But let's just say no for the next two configurations. And then the most important part will be the schema. So we don't have a schema, so we'll say no here. But we would like to create a schema right now, which the question that it will ask, there are two options. For this project, I will use the simple one, which is a single object. And as you can see and note, the files are increasing. There's the API under the backend, which has all the code. And then it will ask, do you want to edit the schema? We'll say yes. Let's edit the schema. This schema is built for you automatically, and I will not change it for now. I will give the example with it. It's as easy as it is. So it will build a to-do object. The derivative, as I said, the at model, it will create actually the table. So this will cause those 5 letters will create a database for you, DynamoDB, and sync with it. The ID is ID. There are scalar types, which ID is one of them. It will be generated automatically for you. String is one of them. And as I said, the exclamation mark at the end means this is mandatory. You have to provide it. So in this case, cannot be null. It's non-nullable. and the name that you provide and the description. So this is like kind of to-do list. So you provide what is the to-do item you need to do and the description of it. Now let's move to the console. You can actually move to the console by saying amplify API console, and this will open the console for you. And you can search for amplify API, AWS Amplify, and you can go to the Amplify. This is what I wanted to show you, the GraphQL microservice that was created for you. This is the project, and it has been deployment successfully. But most of the work will not do it here. But what I wanted to show you, this one, and also the work that was done in the behind the stage. One of the things is the cloud formation. This is very important to see the cloud formation stacks. They build multiple nested stacks, as you can see. Those are 3 stacks that have been created during this exercise. And if you click on it, you'll see multiple items created, the 𝒂𝒄𝒂💄, one of them, the DynamoDB is one of them, and there are a lot of resources being created in the middle. And be careful, of course, because if you're using the free tier, this will cost some money for doing those items for you. So you can go through it, look into the stacks, and you can look into the resources being created as well and see which items that being created, what has been created for you. They add the policies, the IAM rule, all of this being done for you. You don't have to do all of these configurations. It's actually, if you try to do it yourself, you can try, of course, do all of this from scratch, but you will find it's a lot of work. Those are the resources, as you can see, the GraphQL API that's created by AppSync, and there's a lot of code actual. This is the doing the table inside DynamoDB as well. Let's go to AppSync. This is where most of the work will be doing. GraphQL microservice dev environment. This is the one that we Amplify created for us. And of course, if you go to the schema, you will be able, those are the instructions, how to install it. This is for iOS, but we're using JavaScript, of course. So this is how you initialize and being able to configure your project. Let's go to schema. This is the schema. Most of it created for us, but we only provided the type of to do. And if we keep looking, you will find, yeah, this is the type to do that we only provided. And we only provided just the name and description ID. It created 2 more fields for us, created add and updated add. Those will be automatic. If you go to the query, you'll be able to query for the results. You can just by clicking on it, as you can see here, it will generate the query for you. But I want to do mutation first because we don't have anything to show. Mutation is just about the add. It's in the CRUD, it's create. So you can create to do. As you can see, it's very similar to the REST APIs because you have the create and you have CRUD, the CRUD operations. Let's delete the query. Let's create something quickly. I will not focus on it and I will not query back, but I want to show how easy it is. But in the next video or the next session, I will show how it's being done. So let's just put the name. So here, let's say the name writes an article, for example. We can arrange it better by moving the name in the line below. And you can add, as you can see, you can keep add the fields like the description and the ID. So let's add, for example, if you decided to add the description, you go and click in the description and it will add it for you and you can write on it what you want. So let's add description. Move it again. It's messing up my alignment. So in the description field, you can write, let's say write an article about the amazing tool Amplify, and it will generate the ID automatically. And of course, you can copy the ID, click on the execute query. There are documents also. I wanted to show the documents here about the mutation, how to do it, the schema. So if you go to the mutation, you can see create to do, what you need to do, the inputs, what are the items that you need to do. It's generated automatically for you. It's called GraphQL. Let's now execute the query. So it created an item. Here's the ID. Of course, I will not just focus on querying it. The screen here is small for me, but I will show it in the next screen actually. But you can copy the ID from here, create query, and get the data. So just you need to delete the mutation, of course, and then go again and look for query. Click the plus sign to add the query. Here you go, the query, you add the plus sign, you add the query, the get to do, and then you provide the ID. You have to provide the ID to be able to get an item. So here we can have the ID. Yeah, I will took partial ID. It will not show anything. It will show null, of course, because I didn't take the full ID. But I will show it in the next video, or inside the same video, but the next exercise that will go together. We will spend more time inside the query, but I want to get bigger screen to be able to have more real estate and be able to work. The thing that I wanted to show you as well will be the database, as how it's creating the database and how it's creating this item inside the database. It's creating in the DynamoDB, and when you create on the left side you go, so if you click here, this burger menu, and go to the data source, this is the to-do table that's just created for you automatically in DynamoDB. You didn't have to do anything. CloudFormation Templates did it. So when you click on it, it will open a new tab inside DynamoDB, and this is the table. Click on items, you'll find the item that we just added, the to-do item, and it will, if you click on it, you will see that we have the ID and name, write an article, the description string, which write an article about the amazing tool Amplify. So for now, we will just leave this one, and we will go and do the mutation and the query the right way, as we said. So here, this is the console. I had it just added more space so I can work, and now we're trying to do the mutation. We'll have the ID that we will provide, and we need to get back the name. So the mutation, we will add the name. And you can also add it if you type. So if you type, it will give you help. It will autocomplete for you. So you add name, and then let's say to do one that I want to do just first thing to do. And then you can add description if you want, but just write D, it will complete for you, so it will be easy not to mess up which field that you want to add. And this, what I'll do something to do something, and actually you can create this way. All of those are options except the name. And now let's copy the full ID from here and try to do mutation. Of course, if you want to see the items to bring back, you want to see more than the ID, you can add also the name here. The curly braces underneath is just more like the things that you want to see back. Let's create another item to do two, to do another thing, and you can see that this is to do two. Let's take the ID of this item and copy, make sure to do Control-C or Command-C, and delete this mutation, create a query. Yeah, let's see it in the data source as well. Here, if you click on the table, click on items, you'll find that we added. I want to just show you that they will be added automatically when you do the mutation. So it's added new item, to do one, to do something, to do two, to do another thing. Those are the two items created right now. Now let's go back again to the console and go to the query one more time, the queries, and we still have the ID copied. So I'll just get rid of this, create a query, go to get to do. As you can see, it's using get, which is actually a REST, one of the REST HTTP verbs. And here the name, let's add the name. This is where you get. So the second curly braces name, and you can write it down or click on the boxes on the left side, and you can get whatever, any of those things you do. And when you click on it, you provided the ID and you received the 202. Let's get the description as well. Execute the query again, you get the description to do another thing. And of course, you can have update, add, and the ID, created at, execute the query again, it will get all of those items. So whatever you list here are the items that you receive, but you have to list at least one thing because GraphQL is specific. It doesn't get everything. You need to get to be efficient. You need to get certain things. The documentation again, it's called graphical, and as you can see here, it will explain to you the items that you can provide to get in the query, the ID, name. And I explained before the scalar types, which are strings, ID, the integer. It has about 4 scalar types, and the rest you can create yourself as part of the type. Like to do, for example, is now a type that you can use and have a list and query and do some actions on this type. As you can see, it is pretty simple, straightforward, and this is what we'll use. In the future sessions, we just add a new type, it will create a new table, it will create, and you can add those new tables, and we'll start interacting between different microservices. Of course, if you want to create another microservice, this Amplify actually uses something called backend for front end. So you'll always have for every front end a backend. And we haven't got to the front end yet, but as we go through the sessions, I've already have multiple articles how to create React and Redux and fetch data from APIs. We will use those and create queries using Apollo client. I will show how can we query on the front end, and we'll create apps actually end to end, which will be integrating with each other as well. So you might have one UI, one front end that integrates with multiple microservices, and in this case, I prefer always to use the API gateway pattern. Okay, let's summarize what we've done. We created, actually, Amplify created the schema for us, and then we fed Amplify with this schema using Amplify push. It was able to create all the resources on the cloud, on AWS cloud, and we received GraphQL in GraphQL microservice in just a few minutes. As you can see, it's pretty easy to create a microservice using this way, adding data, having interactions. That's why this is what I'm going to use to explain the design patterns. My focus is not into those technologies specific. I would encourage you to go and read more. I might have some videos about to explain Amplify, AppSync, and GraphQL, but I just scratched the surface here because my goal is to explain the microservices design patterns, the interaction, how can you have event bus, how can you have the data flowing between different microservices. And I hope you enjoyed this video and you learned something new from it. And let's meet in the next video. Thank you so much for tuning in.